Hello and welcome to a mini course on adsorption thermodynamics. This is a 5-lecture course, and it's part of the G&L project, which is inspired by the famous quote from G.N. Lewis, "Physical chemistry is everything that's interesting." And certainly the adsorption of molecules onto a surface, or the binding of a ligand or neurotransmitter to a binding site on a protein, are all very interesting subjects. I'm Darren Olness. I'm a physical chemistry professor in the Department of Chemistry at Concordia College in Moorhead, Minnesota. My website is www.darrenolness.com. I'm still having some trouble getting the links to actually link in the descriptions, but you can find the website for this project there as sort of a big link for you to copy. The prerequisites for this course, you should have a good understanding of general chemistry that includes talking about enthalpy, equilibrium constants, some delta G, and entropy as well, or some free energy and entropy as well. If you've taken the Introduction to Physical Chemistry 2 course, that will be sufficient. That is part of our G.N. Lewis project, the basic introductory courses. We will do a little bit of calculus, so this idea of a derivative, and even like partial derivative, but that will be pretty basic. So if you haven't had any calculus, just kind of follow what's going on and then pop out the other side with the equations. All right, so this consists of 5 lectures. The first one is on the Langmuir model. Langmuir model is really something you should know as an aspiring physical chemist or just scientist in general. And this is a model that describes just basic uncooperative binding to sites on a surface. So any kind of situation where we might have some sort of binding interaction that is not influenced by whether or not other binding is taking place. And so it's sort of the first approximation to any kind of a binding model that one would want to look at. And so it's really important to know this. And it's just some really nice application of chemical equilibrium ideas. Lecture 2 will go into some application. Well, lecture 1 will cast this in terms of partial pressures of the binding. Lecture 2 will go into concentrations, so this might be more relevant for ligand binding in neuroscience or in biochemistry. And also so there'll be 3 applications here, just casting the Langmuir model in terms of concentration rather than pressures, looking at the enthalpy of binding, so doing some thermodynamics on that, and then finally an industrial model of gas delivery. So that's kind of an interesting application. Then in lecture 3, we'll look at 2 substances and still stay under the Langmuir model, but talk about competitive adsorption, or competitive binding if we were in, say, biochemistry. Then the last 2 lectures get beyond this basic Langmuir model and talk about 2 important models. The Adair model, where you can have influence, both of these have influences of if a molecule is binding, then does it either help or hurt the binding of another molecule in an adjacent area. And that is called cooperative binding, and cooperativity can be either positive, so binding enhances further binding, or negative, binding disincentivizes or reduces further binding. The Adair model is a fun one to work through. You really have to think about kind of the statistical ideas that go on in addition to allowing for different equilibrium constants depending on whether or not sites are occupied. Then the Hill model is more of an empirical model, and it is one in which just has this Hill parameter that is an empirical parameter that talks about that captures the net effect of cooperativity or anti-cooperativity. And in this lecture, we'll also talk about this cooperativity function that is an important aspect of these ideas, and we'll be able to tie back through to the Langmuir model and to the a very simple Adair model there. All right, so this is the course. If you're out there just participating in the G.N. Lewis projects, hope you enjoy this course. If you are at Concordia College and you're interested in taking this a little bit more formally, perhaps for a single credit or something like that, we could work up some homework and some quizzes and exams. And so if you're interested in that, you can come by and see me for that.